Good evening, dear students. How are you all? So, in our previous class, we have completed biomolecules chapter. I hope you have attended the session. Yes. So, if you want to reply anything, you can use the chat box. Okay. So, in the chat box, you can answer me there. So did you go through the previous sessions? Yes. So we have completed most of the lessons now. Okay. So we are dealing now in the organic chapters. Okay. So in organic chapters, we have seen haloalkenes, haloarenes, then alcohol, phenols, and ethers, then biomolecules. And this is the fourth chapter, aldehyde, ketones, and carboxylic acid. Okay. Fine. Shall we start? Yes. Shall we start the class? Yes. Okay. Okay. Fine. So, yes. So, before going for the question answers, okay. So, aldehyde, ketones, and carboxylic acid. Okay. So, this particular chapter is for 14 marks. Okay. So, this particular chapter, it is for 14 marks, 1-4. Okay. 14 marks. So, so this is the highest. Okay. Yeah. So, if you see the blueprint, so this particular chapter, it fetches you 14 marks. Okay. So, you have to, so don't leave this particular chapter. Okay. So please, if you study this chapter thoroughly, okay, properly, you can score out here. Okay, so please do not skip this particular chapters. Okay, so this particular chapter, as I said, it is for 14 marks. So for 1 marks, you will be getting 2 questions. Okay, that is 2 MCQs questions are for 1 marks each. So 2 questions will come from this. Then 2 marks, you will get 1 question. Okay, 2 marks, 1 question. And 5 marks, 2 questions. And 5 marks, 2 questions. Okay, so long in the long part. In the organic section, as you know, you will be getting long question answer. Okay, so that particular session, you will be having 5 marks, 2 questions. Okay, 5 marks, 2 questions. So now, so the total is for 14 marks. Okay, so the total is for 14 marks. So 1 marks, 2 questions, 2 marks, 1 question, and 5 marks, 2 questions. I hope this is clear. Okay, so now this is the pattern. Okay, this is the distribution of the marks. Okay, blueprint. Now, going for the lesson, that is aldehyde, ketones, and carboxylic acid. Okay, so what we are studying in aldehyde, ketones, and carboxylic acid. Yes. So what are aldehydes, students? What are aldehydes? Yes, what do you mean by aldehydes? How do you represent aldehydes? So aldehyde, ketones, carboxylic acid. Then in the previous session, we have seen alcohol, phenols, ether. So these are all what? These are all functional groups, right? These are all functional groups, right? These are all functional groups. Okay. And we are studying thoroughly in organic chemistry, right? So in the organic chemistry, we are thoroughly studying each group. Okay, we are thoroughly studying each group. So today, okay, we are going to study about aldehyde, ketones, and carboxylic acid. So aldehydes. What do you mean by aldehydes? So in the organic chemistry, okay, in organic chemistry. Now, what is organic chemistry? Okay, so what is organic chemistry? The compounds which are made up of carbon. Okay, in the compounds which are made up of carbon and hydrogen are called as, okay, they are studied under a branch of chemistry which is called as organic chemistry. Okay, so organic, fine. Now, in organic chemistry, there are many organic compounds. Okay, there are many organic compounds which consist of a group which is called as a carbonyl group. It is called as what? It is called as carbonyl group. What it is called as? It is called as carbonyl group. Okay, so in aldehyde, ketones, and carboxylic acid, so there is a functional group. So this, or in organic chemistry, there are many organic compounds. Okay, and they contain a carbonyl group. Okay, so which are the different compounds which consist of carbonyl group? Okay, so aldehydes. So aldehydes, it consists of carbonyl group. Okay, so what is the functional group? It is C double bond O H. Okay, C double bond OH. So this is a functional group which is present in a aldehyde group. So you can see there is a presence of a carbonyl group. Now, next is, so what is the general formula of aldehyde? It is RCHO. Okay, it is represented by RCHO. Okay, this is about aldehydes. Now, next is ketones. Next is what? Ketones. So ketones are represented by C double bond O. They are represented by what? C double bond O. Fine. Now, how are they represented? R, C, double bond O, R dash. So this is the general formula. The functional group is C double bond O, and the general formula, okay, so R and R dash. So these are the alkyl group. Okay, these are the alkyl group or the aryl group. R and R dash can be your alkyl group or the aryl group. Fine. So this is about ketones. Now, next class of compounds are carboxylic acid. Next is what? Carboxylic acid. Now, carboxylic acid. Okay. Now, in carboxylic acid, okay, carboxylic acid consists of C double bond OH. Okay. So this is the functional group, C double bond OH. Okay. Now, what is the general formula? It is RCOOH. This is the general formula, that is RCOOH. Okay. So aldehyde represented like this. Then ketones are represented like this. So this is a general formula. Okay. And your Carboxylic acid is represented by RCOOH. Okay, fine. So there are different, again, carbonyl compounds. Okay, you have acyl halides. You have acyl halides. Okay, that is R C double bond O X. Then is acid anhydride. Okay. Next is acid anhydride, that is C double bond O, C double bond O. Okay. Then is acid amides. Next, okay, where you have a carbonyl group is acid amides, that is C double bond O NH2. And next is esters. Okay, esters is represented by C double bond O O R dash. Okay, so these are all the organic compound which consist of a carbonyl groups. Okay, so these are all organic compound, they consist of carbonyl group. I hope this is clear. Okay, so this is about, so here in this particular chapter, we are, these are all we are studying about the carbonyl compounds. Okay, so some of the carbonyl compounds we are studying about aldehyde, ketones, and carboxylic acid. Okay, fine. Now coming for the main thing. So here we are going to study the firstly, okay, I hope, so in this particular chapter, so whenever you're considering the organic compounds, so you need to know the IUPAC system. Okay, you need to know the IUPAC system. So please study the IUPAC system in case of haloalkanes, haloarenes, alcohol, phenols, ethers, okay, aldehyde, ketones, and carboxylic acid, amines. Okay, so these all particular chapters. So please study the IUPAC system. So for IUPAC also a compound can be given, and based on that they can ask you the IUPAC name of that particular compound. Okay, then so there are some few name reaction. Okay, so there are some important name reaction as we have seen in our previous classes also. Okay, in the previous lessons also. So there are some important name reaction which we have dealt. So same way in this particular chapter also there are some important named reaction. So which are very important and that you have to practice. So as I've said in the previous sessions also, in organic chemistry, you cannot bahar the reactions. Okay, you cannot bahar the reaction, you have to practice them, you have to practice. Okay, so you have to write and write. So as many times you practice, okay, so you will be perfect in that particular reaction. Okay, so preparation. So in this okay, so preparations are there, different preparations of aldehyde, ketones, and carboxylic acid, then chemical properties, physical properties. Okay, so these are things we are going to cover through the MCQs and the question answers. Fine. Okay, so we'll start with the MCQs now. Yes, students, shall we start with the MCQs? Okay. The use of dry HCl in the reaction of an aldehyde with a monohydric alcohol results. So the use of dry HCl. Okay, we are making use of dry HCl in the reaction of an aldehyde with a monohydric alcohol. Monohydric alcohol. Yes, what do you mean by monohydric alcohol? Yes, students, can you tell me what do you mean by monohydric alcohols? So when there is a dry HCl, okay. So what happens with the dry HCl? So when there is a, what we are making use of dry HCl in the reaction of aldehyde with a monohydric alcohol results into, yes, I'll write the things here, just a second now. See here, monohydric alcohol means, suppose if I take a aldehyde, okay, if I take a acetaldehyde, CH3CHO, this is acetaldehyde. Monohydric alcohol means what? Okay, mono means single. When you have a single OH group, suppose I take a ethyl alcohol. So what we are doing, we are taking a aldehyde, we have taken a aldehyde and we have reacting it with a monohydric alcohol, okay, in the presence of dry HCl, in the presence of dry HCl. So what will be the, why we are making use of this dry HCl? Okay. So what will be the product? The product will be CH3CH, okay, then OC2H5 twice. Fine. So this is the, so what is happening here? Yes, students, why we are making use of dry HCl here? Why we are making use of dry HCl? Because there is a presence of, we are making use of a hemiacetal. Okay, there is a formation of hemiacetal in the, okay, in the, what you say, in the intermediate product is hemiacetal. So acid aldehydes, okay, they react with the aldehydes. So these are the aldehydes. Okay, that is you are having CH3, C double bond O, H like this. So aldehydes, they react with the alcohol, okay, in the presence of HCl. Why? To yield a alkoxy alcohol. Okay, it yields a alkoxy alcohol intermediate, which is known as the hemiacetal. Okay. Now this hemiacetal, what happens further? Again, they react with one more molecule of alcohol. Okay, one more molecule of alcohol, and it forms a dialkoxy. That is, this is a geminal product, that is CH3, CH, okay, OC2H5 and OC2H5. So this is a hemiacetal product, that is acetal. So this forms a acetal plus water molecule. Okay. So what is happening here? So there is a increase in the electrophilicity. Okay, there is a increase in the electrophilicity of the carbonyl carbon. So this H plus ion, okay, from this what is that? What you say? What is happening here? So this, whatever the HCl is there, which we are making use of, it will generate what? It will form, it will help in the electrophilicity. Okay, it will help in the electrophilicity of the carbonyl carbon. So H plus ions are produced by this dry HCl. Okay, so those, they increase the electrophilicity of the carbonyl group. So we are making use of dry HCl in this particular reaction to increase the electrophilicity. Okay. The common test answered by ethanol and ethanol is A. Iodoform reaction, B. Carbalamine reaction, C. Sand-Mears reaction, and D. Woods reaction. Okay. Shashank has answered it as iodoform reaction. What about others? Yes. So before that, what is iodoform test, students? Can anyone tell me what is iodoform test? What is iodoform test? Yes. What is iodoform test? What is iodoform test? So what is iodoform test? Yes, it tells you the presence of aldehyde or the ketone. Okay, good. Okay, fine. So I'll explain you. So yes, Shashank has answered it right. Fine. So the iodoform test, what it tells you the presence of either the aldehyde or the ketone. Okay, in which the methyl group is one of the group which is immediately connected to the carbonyl carbon. Okay, so this tells you whether it is okay. So the whether it is aldehyde or a ketone. Fine. So this is the test. So what? So ethanol. What is ethanol now? Okay. Now ethanol. Okay, ethanol. Just a second. I'll show you ethanol. Okay, ethanol is what? Ethanol is a aldehyde, that is CH3CHO. Okay, ethanol. I'll write here. I'll write in words only. Okay, ethanol. So ethanol, when it reacts, okay, with iodoform test, it gives you a brick red color. What it gives you? It gives you a brick red PPT. Okay. With if you do it with if you do it with Felling solution, okay, if you do it with Felling solution, it will give you a brick red PPT. Okay. Now wherever your ethanol, okay, with Felling solution, it does not react. It does not react. Okay. Now ethanol. Okay. Ethanol. Uh, Now ethanol. Okay. If you react it with your iodoform test. Okay. What will happen with iodoform test? Because ethanol and ethanol, okay, both this test will react. Okay, both this test will react. So they now when you do with carbolamine test, Woods reaction, okay, Sandmeier's reaction, so ethanol will give different ppt and ethanol will give you different reaction. Okay, but when you do iodoform test, they both will respond. Okay, they will both react to the, they both will react to the iodoform test. Okay, so the common test which is answered by both ethanol and ethanol is your iodoform reaction. Okay, because when you are comparing the other reactions, okay, that is carbolamine reaction, Sandmeier's reaction, Woods reaction, when they react, ethanol is a aldehyde and ethanol is a alcohol. Okay, so alcohol will react separately and your aldehyde will react separately with the different reaction. But when you do a iodoform test for your ethanol as well as the ethanol, they both will respond equally. Okay, they both will respond equally. Fine. Moving for the next question. The solubility of carboxylic acid in water will A, increase with increase in number of carbon atoms. B, decreases with increase in number of carbon atoms. C, decreases with decrease in number of carbon atoms. D, neither decreases nor increases with increase in number of carbon atoms. Yes, what will happen to solubility? Yes, students, what will happen to solubility? Okay, Shashank has answered it as increases with increase in number of carbon atoms. Okay, what about others? Yes, students? Try to answer. I'll tell you the answer later. Do okay, no mind if you give the wrong answers, but you have to try. Okay, you have to try answering it. Okay, no one is perfect here, so try giving the answers. So solubility of carboxylic acid in water. So carboxylic acid, if you add in water, okay, what will happen to solubility? Whether it will increase with the increase in number of carbon atom, it will decrease with increase in number of carbon atom, whether it will decrease with decrease in number of carbon atom, neither increases nor decreases. What will happen? Tell me. Yes. See here, what will happen to solubility is, okay, so carboxylic acid, they will form the hydrogen bond. How it is? C double bond O OH. Okay. So carboxylic acid, they will form hydrogen bond. You know what is hydrogen bond? Okay, hydrogen bond is formed between the hydrogen and the most electronegative uh, atoms like oxygen, fluorine, okay, etc. So hydrogen bond is formed. Now here, so carboxylic acid, they form the hydrogen bonds with water. Okay, they form the hydrogen bonds with water. Okay, and hence they are soluble. Hence they are soluble in water. If they are forming hydrogen bond with water, okay, now this is water molecule. Just a second, I'll draw it properly here. Okay. Okay, so it is forming the hydrogen bonding. Okay, so this is the hydrogen bonding. So it will form hydrogen bonding. So what will happen? So as carboxylic acid, they form the hydrogen bonds with water, thus they are soluble in water. Okay, but as the number of carbon atom increases, as the number of carbon atom increases, this carbon atom, okay, as the number of carbon atom increases, okay, what will happen? In acid. So as the number of carbon atom increases in the acid, then hydrophobic nature. What do you mean by hydrophobic nature? Hydrophobic and hydrophilic. Hydrophobic means water hating. Okay, water hating. Hydrophobic means water hating. So as the number of carbon atom, this number of carbon atom increases, then hydrophobic nature of water increases. Okay, the hydrophobic nature of water increases. What will happen? The hydrophobic nature of water increases. Okay, and thus the solubility will decreases. So what will happen? It will decrease with the increase in number of carbon atom. So what will happen to solubility? It decreases. Okay, solubility will decreases with the increase in number of carbon atoms. Why? What is the reason? Because as the number of carbon atoms in the acid, okay, in the acid increases, what will happen? As the number of carbon atom in the acid increases, then the hydrophobic nature of the water increases. Okay, so this is a reason. So decreases with the increase in number of carbon atoms. So the answer is B. I hope this is clear. Yes, student? Is it clear? Shall we move further? Yes, any doubts still here? Any doubts? If you have any doubts, you can ask me in the chat box. Yes. Okay, fine. Okay, so these were the three questions which we have seen till now. So the next question is, the reagent used to convert carbonyl compound to hydrocarbon is A. Sodium borohydride, B. Lithium aluminum hydride, C. Zinc amalgam and concentrated HCl, and D. Hydrogen in platinum. The reagent used to convert carbonyl compound to hydrocarbon is. Okay, Shashank has answered it as C. Nikita has answered it as C. Okay, Kirtana has also answered it as C. Yes. Yes, students. Yes. Good. Okay. So yes, the reagent which is used is what? It is zinc amalgam and concentrated HCl. Okay. So we are using this particular, just a second, I'll write it here. Okay, so wherein we are converting our carbonyl compound. Okay, we are converting our carbonyl compound to a what hydrocarbon. Okay, we are converting it to hydrocarbon in the presence of zinc amalgam. Okay, and concentrated HCl, in the presence of zinc amalgam and concentrated HCl. So what we are doing? So it converts your ketone. Okay, always this particular reagent, that is zinc amalgam, or you can take sodium amalgam. Okay, NaHG. Okay, zinc amalgam or sodium amalgam. So these reagents in the presence of concentrated HCl, they convert the ketones to hydrocarbons. Okay, they convert into ketones to hydrocarbons. So what is happening? The carbonyl group is reduced to methylene group. Okay, it converts the carbonyl group into methylene group. Okay, so this is the answer. C is the answer. Okay, okay. Next question. The reagent used during conversion of aldehyde to acetyl by reacting with monohydric alcohol is A, dry HNO3, B, dry H2SO4, C, dry HCl, and dry H3PO3. We have seen this particular in the first, okay, in the first itself. They have asked what twisted, okay, in the form of twist question. So we have seen this in the first MCQ. Okay, the why dash is used in aldehyde and ketone, sorry, aldehyde and alcohol. Yes, it is dry HCl. Good. Sashank, yes, it is correct. Nikita, it is correct. It is dry HCl. Okay. So what we are doing, we are reacting the aldehyde and alcohol. Okay. In the presence of dry HCl, it forms hemiacetal. What it forms? It forms hemiacetal. Now this hemiacetal form, that is a intermediate. Okay. Now this hemiacetal, again, it reacts with 1 mole of alcohol. It reacts with 1 mole of alcohol and it forms what? It forms acetal. Okay, it reacts and it forms a acetal. So what is used? It is dry HCl. Yes, good. Okay, so remember like this. Okay, so the question can be twisted. The question can be twisted. So all the MCQs question won't be a direct question. Some will be what twisted question. Okay, applicative type questions will be there. So do like that. Acetophenone does not give addition compound with NaHSO3 due to acetophenone. Acetophenone does not give addition compound with NaHSO3 due to A, steric hindrance, B, inductive effect, C, electromeric effect, and D, electrophilicity. Okay. Sashank has answered it as A. Okay. What about others? Acetophenone. Acetophenone does not give an addition product. What is the reason? What is the structure of acetophenone, students? What is the structure of acetophenone? I'll draw it here. Okay, now you can try. So this is acetophenol. It is called as methyl phenyl ketone. Okay, methyl phenyl methyl phenyl ketone. The name is methyl phenyl ketone. Okay. So this particular acetophenol, it does not react with NaHSO3. NaHSO3. Okay. It does not give you a addition product. It is due to what? Now, whenever the addition product, okay, where it will add to this carbonyl carbon. Okay, to the carbonyl carbon, the addition takes place. Okay, so the addition takes place at the carbonyl carbon. So it is due to what? It is due to steric hindrance. Okay, remember that, due to steric hindrance. Okay, it is due to steric hindrance. The addition does not takes place. Okay. So it's here, if you have a acetaldehyde, okay, if you have a acetaldehyde, okay. So when you have this what? It gives you a steric hindrance. Okay, it gives you what? It gives you, it is due to steric hindrance. So these are called as what? These are aromatic ketones. Okay, these are all aromatic ketones. So the methyl phenyl ketone, because you have a phenyl group, right? You have a phenyl group. So these are called as aromatic ketones. So these aromatic ketones, okay, these are less reactive. As compared to the aliphatic ketones, these are less reactive. Okay. And ketones, okay, ketones as compared to the aldehyde, ketones are less reactive. Okay. And hence acetophenone, what happens to acetophenone? They do not react. Okay. They do not react with NaHSO3. Fine. Next question. Because it is a steric hindrance means what, students? Steric hindrance means bulkier group. Okay. There is a presence of which group? There is a presence of there is a presence of bulkier group. Okay, when you have a bulkier group, then the reaction does not take place. Okay, then it will the addition, it is not taking place because there is a steric hindrance. CHOEs. What is the IUPAC name of CHO? A formic acid, B formaldehyde, C methanol, and D methanol. Okay, Shashank has answered it as methanol. B. Okay, Shashank. C. B. Okay, Deepak and Nikita has answered it as B. Okay, others? Yes, what about others? Okay, Vedvati has answered it as C. HCHO. Yes, it is methanol. Okay, it is C. It is methanol. Okay, the IUPAC name is methanol. Fine. So please remember the IUPAC name. IUPAC name are very important. Fine. Next question. Shall we move for the next question? In stiffened reaction, A, alcohols are converted into aldehydes. B, carboxylic acids are converted into aldehydes. C, nitrile compounds are converted into aldehydes. And D, haloalkanes are converted into aldehydes. Okay, Nikita, Deepak, and Shashank, Vedvati have answered it as C. Okay. Okay. Can you see the Stephen reaction here? Yes. Stephen reaction. Can you see Stephen reaction? What is happening in Stephen reaction? The alkyl nitriles. Okay. So nitriles, cyanide groups. Okay. Nitrile is nothing but cyanide group. So nitriles, what we are doing? We are doing reduction. Okay. We are doing reduction. We are doing reduction on that with the help of stannous chloride. Okay. In the presence of hydrochloric acid, and you get a imine. This is what this is called as imine. Okay, I'll write it here. So your nitriles, so these are nitriles. So nitriles using these, this is a reducing agent. Okay, this is reducing agent. You are converting them into corresponding imines. Okay, now this imines, what is happened to this imines? Further, you are doing hydrolysis. We are doing what? We are doing hydrolysis on this imines, and you get a corresponding aldehyde. Okay, we are doing acid hydrolysis here. Okay, we are doing acid hydrolysis and corresponding aldehydes we get. Okay, so what was the question? Once, so we have seen now stiffened reaction. Now we'll see what was the question again. Okay. In stiffened reaction, now you can tell me. Yes, it is nitrile compounds are converted into aldehyde. So it is option number C. Okay, good. Okay, next question. Carboxylic acid exists in dimeric form even in wafer phase due to carboxylic acid, they exist in dimeric form. Carboxylic acids exist in dimeric form even in vapor phase due to. Yes. What is the answer? Okay. Sashank, Vedpati have answered it as A. Yes, it is due to hydrogen bonding. Okay, we have seen this. So due to hydrogen bonding, okay. So this is your carboxylic acid. So they exist in dimeric form. Okay. So there is a what? They will undergo a intermolecular hydrogen bonding. What they are forming? They are forming intermolecular hydrogen bonding. So between the other molecules. Okay, inter means between two different molecules, there will be what? Hydrogen bonding. So even in the vapor phase, okay, what will happen? This hydrogen bonds, they will remain intact. They remain intact. They do not get separated. They will remain, they will hold tightly. Okay. And so those, most of this carboxylic acid, even in the dimeric form, they will be in okay, they will exist in dimeric form due to this hydrogen bond. Okay, so peptide bond, where you know peptide bond, it is in proteins. Okay, metallic bond in the metals, ionic bond between the two ions. So these are all wrong options. So option A is the correct answer. Carboxylic, okay. Aldehydes are generally more reactive than ketones in nucleophilic addition reactions due to A, neither steric nor electronic reason. B, either steric or electronic reason. C, either both steric and electronic reason. And D, formation of hydrogen bonding. Yes, why aldehydes are generally more reactive than Sashank has answered it as C, Nikita has answered it as D. Why aldehydes are generally more reactive than ketones in nucleophilic addition reaction? Okay, now it is due to what? It is due to option number C, both steric and electronic reason. Okay, it is due to both steric and electronic reason. Now, when you have a aldehyde, okay, when you have a aldehyde, at one side you have a alkyl group and at one side you have a hydrogen group. When you have a ketones, okay, when you have a ketone, so both are the alkyl or one can be a aryl group. So what will happen here? There will be steric hindrance. Okay, there can be two large substituents. Okay, there can be presence of two large substituents. So because of the presence of two large substituents, what will happen in the ketones? It will hinder the what is that nucleophile attack of the nucleophile to the carbonyl compound because of the presence of this two carbonyl carbon. Okay, but in case of your aldehyde, you can see there is only one. From here, you have only hydrogen. So easily it can attack the nucleophile can easily attack this carbonyl carbon. So only one substituent is present. But in ketone, both the substituents can be a large substituents. Okay. So because of steric as well as the electronic reason, aldehydes, okay, they are generally more reactive. Fine. Yes, option number C is the right answer. Next. Aldehydes which answers Carinzaro reaction does not contain A beta hydrogen, C B gamma hydrogen, C alpha hydrogen, and D delta hydrogen. Nikita has answered it as C. Vedvati has answered it as C. Shashank has answered it as A. Yes, students. So what is Carinzaro? We'll see Carinzaro then. Okay, if you have confusion, fine. We'll see the Carinzaro reaction also. Then you can. Okay, here is the Carinzaro reaction. Okay, you can read here now. Aldehydes which do not have which hydrogen? Alpha. Okay, which do not have alpha hydrogen cannot undergo self-oxidation and reduction. Okay, on treatment with concentrated alkali. So in this reaction, one molecule of aldehyde is reduced to alcohol while the another is oxidized to carboxylic acid and salt. So if the aldehydes do not have alpha hydrogen, okay, they do not go Carinzaro reaction. So the answer is, which is the correct answer? Yes, it is C. Yes, the answer is right. It is C. Yes, Kirtana with Vedvati have answered it right. It is C. Okay, fine. Next question. In Clemmensen reduction, carbonyl compound is treated with dash to form corresponding hydrocarbon. So what is Clemmensen reduction? A zinc amalgam plus HCl, B sodium amalgam plus HCl, C zinc amalgam plus HNO3, and D sodium amalgam plus HNO3. Yes, Deepak has answered it as A. What about others? Okay. Vedvati, Sashank has also answered it as A. Fine. We'll see the Clemmensen reduction. Okay. Here you can see. So what is happening here? The carbonyl group of the aldehyde and ketone is reduced to CH2. That is your hydrocarbon. Okay. Methylene group. Okay. And in the presence of zinc amalgam and concentrated HCl. So this is your Clemmensen reduction. Yes. Nikita, Sashank, Vedvati, Deepak have answered it right. Good. Okay. So it is zinc amalgam in the presence of HCl. Okay. So option number A is the right answer. So this is the right answer. A. Yes, right. Next. Next question. The strongest carboxylic acid among the following is A. Acetic acid, B. Trichloroacetic acid, C. Trifluoroacetic acid, and D. Dichloroacetic acid. The strongest carboxylic acid among the following is. Okay, Nikita, Shashank have answered it as A. Which is the strongest carboxylic acid? Acetic acid, trichloroacetic acid. Okay, acetic acid is CH3COOH. Okay, then trichloroacetic acid is this. Okay, 3CH3. CH, Cl2, COH. Just a second. CCl3, COH. Okay. This is trichloro, then trifluoro acetic acid, and dichloro, CCl2. This can be CHCl2, COOH. Okay. These are the structures. Now you can tell me which is the strongest carboxylic acid. Yes, students. Okay, Vedvati has answered it as C. Kirtana has answered it as A. Okay. Now these are the structures you have seen A, B, C, and this is D. Okay. Now what you can see. Okay, Shashank has answered it as A. So what you can see here with the structure now here. This is what type of group? You have to answer. Okay. So this is what type of group? What is this type of group? What is this group? And what is this? What is CH3? CH3 is a alkyl group. Okay. So alkyl group is what? Alkyl group is a electron donating group. Okay. Electron donating group. Okay. But this fluorine, chlorine. Okay. Then sometimes phenyl groups. So these are what? These are all electron withdrawing group. Okay. They withdraw the electrons. What they do? They withdraw the electron towards itself. Electron donating means they give electrons. So these chlorine, fluorine, they will withdraw the electrons. So what will happen? Here the acetic acid will be the weakest. This will be the weakest acid. Okay. And among the all given acid. And here you can see when you are seeing between chlorine and fluorine. Okay. Fluorine, chlorine, bromine, iodine. Okay. So fluorine is the, what you say, it is the highly electronegative. Okay, so this will have what it is the it will have the what do you say, good tendency to withdraw the electron. So you can see there are three fluorine atoms. Okay, now here there are two chlorine atoms, there are three chlorine atoms. So this is also wrong. Okay, here what will happen? The electron withdrawing group will it will be slightly this. So first weakest acid, then second this will be weakest. Okay, this will be if I give this the fourth number, this will be third number. Okay, then this will be second number and this will be the first number. Understood? So the strongest carboxylic acid is trifluoroacetic acid. So when we are comparing between fluoro and chloro, Okay, so dichloro, only two chlorine groups. So this will be the second last. Then trichloro and trifluoro, when you compare the halogens, fluorine is the highly electronegative element. So this will be the, it will have the good tendency for withdrawing group. Okay, so it is a electron withdrawing group. Fine. So I'll take option number C. Understood? So option number C is the right answer. So Vedavati has answered it right. Good. Okay, fine. Next question. Carboxylic acids are obtained by treating Grignard reagent with A, ice, B, water, C, carbon dioxide, and D, dry ice. What is dry ice, dry ice, students? What is dry ice? Can you tell me what is dry ice? Dry ice is what? Yes, it is good. It is solid carbon dioxide. So carboxylic acid, if you treat it with, yes, good. Vedvati Shashank has answered it right. So carboxylic acid, okay, if you are obtained by treating your Grignard reagent. So RMGX is your Grignard reagent, which is also called as organometallic compound. Okay, this is also called as organometallic compound. So carboxylic acids are obtained by treating Grignard reagent with A, ice, B, water, C, carbon dioxide gas, and D, dry ice. Okay, so it with dry ice, that is your solid carbon dioxide. Okay, so it will give you carboxylic acid. It gives you carboxylic acid. So if I give like this solid carboxylic acid, so it will form an intermediate complex here. First, it will form an intermediate complex. So what intermediate complex? I'll write it here. So RMGX, okay, if I take R as CH3, I'll take R as CH3 here. So I'll take R as CH3, CH3 Mg, I'll take Dr. Okay, then solid carbon dioxide, you get CH3, COO, MgBr. So this further on hydrolysis, acid hydrolysis will give you CH3, COOH plus MgBr and OH. Fine. So what is the answer? It is with dry ice. So carboxylic acid are obtained by treating your Grignard reagent with solid uh, yes, with your solid carbon dioxide. Good. Next question. Ammonical silver nitrate solution is called as A. Felling solution, B. Schiff's reagent, C. Benedict's reagent, and C. Tollens reagent. Ammonical silver, yes. Vedvati Sashank has answered it right. It is D. It is called as Tollens reagent. It is called as Tollens reagent because it will give you a silver mirror test. Okay, it gives you silver mirror test. Okay, so it is called as ammonical silver. It is called as ammonical silver. Fine. Next, addition of alcohols to aldehydes gives a gem dialkoxy compound known as. One more same question. This is a third time. Okay, they have asked it differently. Addition of alcohols to aldehydes gives you a gem dialkoxy compound which is known as A. ketal, B. acetal, C. aldol, and D. none of this. Yes, Sashank, your answer is wrong. Not aldol. We have seen this. This is the third time. The same question is asked in the twisted manner. Yes, Nikita has answered it as B. Yes, you get a acetal. Good. Nikita has answered it properly. It is acetal. Yes, Vedvati have also answered it as B. So addition of alcohols to aldehydes, which gives you a gem dialkoxy compound. It is a acetal. Okay, first the intermediate form will be hemiacetal. So this hemiacetal, when it reacts with one more molecule or of this what alcohol, then it gives you a gem dialkoxy compound, which is called as acetal. Okay, fine. Next, nitriles are converted into ketones by treating with A. Dialkyl cadmium, C. Acyl chloride, C. Grignard reagent, and D. chromyl chloride. Sashank has answered it as C. Nikita has answered it as A. Nitriles are converted into ketones by treating with Grignard reagent. Okay, with Grignard reagent. Yes, Shashank answer is right. So if you treat your this what with Grignard reagent, they can be converted into ketones. Okay, they can be converted into ketones. So treatment of nitriles with Grignard reagent, which will further undergo hydrolysis. Okay, to give you a ketones. It will yield you what? It will yield you ketones. Okay, remember this. Next one. Carbonyl carbon is a electrophile, B nucleophile, C amphoteric, and D acidic. Amphoteric means neither acid nor base. Okay. Amphoteric. It acts like both. Yes, carbonyl carbon is a acidic. Okay. What about others? Carbonyl carbon. This carbonyl carbon. Suppose this is what? This is a nucleophile. So nucleophile is attacking our electrophile. So this is a electrophile. Okay. So carbonyl carbon is a electrophile. A. Yes, Vedavati has answered it right. It is A. Fine. Last two questions, then we'll end the session. Okay. 40% formaldehyde solution used to preserve biological specimens is called a solution of formaldehyde, which is 40%, which we are making use for preserving the biological specimen. Okay. So A, dilute formaldehyde, B, concentrated formaldehyde solution, C, aqueous, or D, formalin solution. Yes, Shashank, the answer is right. It is formalin solution. Okay, yes, Kirtana, Vedvati have answered it right. It is formalin. So formalin is a solution which is 40%. Okay, it consists of formaldehyde solution which is 40% and it is used to preserve the biological specimens. Okay, it is used to preserve the biological specimens. Next, sodium salt. Sodium salt. Okay, sodium salt of carboxylic acids are converted into hydrocarbons by A, dehydrogenation, B, decarboxylation, C, dehydration, and D, dehalogenation. Sodium salt of carboxylic acid. Sodium salt of carboxylic acid are converted into hydrocarbons by, how are these converted into? Sodium salt of carboxylic acids are converted into hydrocarbons by, okay. Itna Sashank has answered it as D, dehydrogenation. Okay. Sodium salt of carboxylic acid. Sodium salt of carboxylic acids are converted into hydrocarbons by dehydrogenation, decarboxylation, dehydration, dehalogenation. And see properly. What is dehydrogenation? Dehydrogenation means what? It refers to the removal of hydrogen. Okay, H2 molecule. Decarboxylation means removal of carbon dioxide group. Okay, that is carbon dioxide. Dehydration means water molecule. Dehalogenation means HBr. Okay, halogen group is removed from here. Okay. Dehalogenation means only halogen group. Okay, only Br. You can take it as X2 group. Okay, X2 group. So sodium salt of carboxylic acid, when they are converted into hydrocarbons, there will be elimination of this carbon dioxide. Okay, so it is decarboxylation. It results into decarboxylation. Answer number, it is B. It is B. Okay, you can see carboxylic here. Okay, so there is a CO2 group. Okay, so your sodium salt of carboxylic acid can be converted into hydrocarbons. Okay, it can be converted into hydrocarbons by decarboxylation. Okay, so are these questions clear? Yes, so we have seen 20 MCQs in today's session. Are these questions clear? Yes, students. Any doubts in today's session? So if you have any doubts, you can leave it in the chat box. Okay, fine. So no doubts. Fine. So in today's session, we have seen the MCQs. Okay. So in the next class, we'll be seeing some of the name reactions. Okay. And we are going to solve some questions. Okay. We'll see some 2 marks questions, 2 marks, 3 marks questions. Okay. Fine. So I'll end the session here. I hope you have understood today's session, whatever has been explained. Okay. So whatever the things are told, please revise them. Please practice them. As I've told earlier, name reactions, all the mechanisms cannot be bahated in organic chemistry. You need to practice. As many times you write them, you will be well versed with the things. Okay, so I hope today's session is clear. You might have uh, understood all the things. Okay, so I'll end the session here. We will meet in the next class. Thank you. Have a good day.